Hello everyone, in this chapter we are gonna start a new concept which is two-dimensional arrays. So in the previous class we have talked about something about one-dimensional array. In one-dimensional array what we were doing is that we were storing, let's say we have a list of elements, we have list of integers, and in that we want to store them. Then we can store that list of elements in a single dimension array, in a 1D array. And a one dimensional array looks like this. Let's say I have marks for marks of particular student, um, uh, math, physics, chemistry marks. So what I can do is that I can directly write, let me draw int student1, and I will create the array is equals to 98, 99 and 100. So this will be the marks of a single student, and this representation we call this as a single array, or you can say one dimensional array. Now when it comes to a two-dimensional array, we will store the elements in the form of rows and columns. Here you can see that in 1D array the elements we are storing, it is in a single dimension format. Either you can put elements in this direction or you can put elements in this backward direction. But when it comes to two-dimensional array, you can fill elements, you can access elements in a two-dimensional format, and the filling happens in the form of rows and columns. And if I have to tell you an example, then the example which I can think of, let's say for single student you have created a one single array, right? But let's say that they are a group of students in a class, they might be 20-30 students, and for all these 20-30 students the subjects is going to be same. So in that case what we will do is that we will create a two-dimensional array, and in that two-dimensional array we're gonna store the marks of all students. Here I'll show you example that let's say these are math marks, math, physics, chemistry. Now there is student S1, S2, S3. So what we will do is that we'll store the max marks of S1 student, let's say 98, 97, 96, 80, S2 student marks 83, 85 and 98, 97, 99. Okay, so this representation you can see that within a array, this is a representation of two-dimensional array. In this you are gonna store the marks of all students in a class. So you can see that you can write, or you can say this particular array name as class, and you will represent it with two square brackets. Like this two-dimensional array works. So the definition of a two-dimensional array is that you are storing the elements in the form of rows and columns. That is the definition of a two-dimensional array. And in two-dimensional array you can move from let's say you are at a particular position, you can move on top, bottom, left, right. Okay, so this is how things works when it comes to a two-dimensional array. Now this is the visualization of a two-dimensional array. And one more thing is that key, like this is very similar to matrices which we have studied in 11th and 12th. Like in 11th and 12th when we are studying math, now we have we have studied about matrices. So what is the representation of a matrix? Like we are going to store the elements like this: 2, 3, 5, 7, 8, 9. So this is a representation of a matrix, and matrix is nothing but a two-dimensional array. Like this we have n-dimensional different arrays, and mainly when it comes to DSA we're gonna study only two things. One is one-dimensional array, number two is two-dimensional array. Now I hope you have understood the difference between one-dimensional array and a two-dimensional array. In one-dimensional array we are gonna store the elements in a line format, right? And we can move in this direction or in this direction only. But when it comes to two-dimensional array, we can store the elements in this format, or we can move, like traversal will happen top and bottom, left and right, and the element storing happens in the form of rows and columns. And what is a row? The horizontal line which we represent, this is known as a row, and the vertical line which represents the vertical element, this is known as column. Okay, and you can see that here they are they are two rows and three columns, column 1, column 2 and column 3. Okay, so we represent this matrix, this two-dimensional array, in this format, m cross n. Here m represents the number of rows, and n represents the number of columns. Okay, so I hope you have understood the theory part of it, ki what is two-dimensional array, how to use them, why we use them, and what are the real-time example of this. So this is a real-time example of two-dimensional array like this. Let me search key different examples of two-dimensional array. Okay, so different real-time example of 2D array. You can see digital is image is an example of 2D array, pixel, chessboard, each square. Like these are the practical example of two-dimensional arrays. Okay, you can see this is how a two-dimensional array looks like. Now let's go back to our board. So we have talked everything related to two-dimensional array, the theory concept related to it, and all those sort of things. Now how to create them, how to use a particular two-dimensional array. So for that, let us consider, we are studying Java, right? So let us consider an example, and with that example I will show you the code part of that as well. So let's say I have my array 0 1 2 3 4 5 6 7 8. This is a two-dimensional array, and here we have 3 rows and 3 columns. So the representation will be 3 cross 3, or you can say m cross n, and here the m is 3 and the n is 3. Okay, got it. Now how to create it in Java, how to access a particular element, and all this sort of things. Now if you recall, okay, I'll tell you, but before that let us see how we can create a two-dimensional array in Java. So we already know how to create a one-dimensional array. I'll just give int arr, and in that I'll give 1 2 3 like this. This is how we used to create a one-dimensional array. Now for the creation of a 2D array, what we do is that we'll create, let's say my array name is arr. Okay, so here I will give int arr, and I'm going to create a like two-dimensional array, right? So I will give two square brackets is equals to, and I'm gonna store the elements in row wise. So here I'll write 0 1 2, this is my row 1, comma 3 4 5, comma 6 7 8. So here every individual parenthesis, every internal parenthesis represents rows. Okay, and the total number of internal parentheses I have, total number of pairs of internal parentheses I have, this represents my column. Okay, so this is how we create a two-dimensional array directly with the elements. Now let's say ki user is giving me elements. I will show you ki how to take input, all this sort of things, but let's say that I wanna access 4. So can I track down the position of 4 using rows and columns? You can see that if we already know that in arrays, when it comes to Java, the indexing begins with uh, 0. So here this 0th element has 0th row and 0th column. The position of this element is 0 comma 0. Now you can see that the position, the element 1 has is in 0th row and first column. So the position of this particular element will be 0 comma 1. Now what is the position of 8? You can see that it is in the third row and third column, right? So the position of 8 will be 3 comma 3. Similarly, if you take 4, 4 is in second row and second column. So the position of 4 will be 2 comma 2. right? Second row, second column. Now, as I told you that indexing starts from 0 in Java. So here we have to reduce it by -1. So the position of 4 will be 1 comma 1. I hope you have understood key how we track elements. So to access a particular element, let's say I want to access 4. So we already know that the position of 4 is first row, first column. If our rows are starting from 0, now what we can do is that we will write ARR of 1 comma 1. This will give us 4. Like this we can track, or you can say you can access elements in a two-dimensional array. So instead of writing this in my whiteboard, what I will do is that I'll go to my Visual Studio Code and I'll directly show you that. So here I'll create a new variable. I hope my screen is clear. Yeah, it is clear. uh, Maximize this, create a new file, and I'm gonna write it 2D array, 2D array dot java. Okay, now here let me import everything. I'll write my boilerplate code, import java dot util dot star. Now let me zoom a little bit such that you guys can see. Now here I'll create a function. I'll create my class public class 2D array, right? 2D array, 2 array, and write our array. Now we got all this sort of things, but let me remove these things for now. Okay, and this things as well. I don't need all this right now. So yeah, what I'll do here is that key, first of all I'll create my simple 2D array. So int arr is equals to, and I'm gonna store elements 1 2 3 4 5 6 7 8 9. Okay, got it. Now to access a particular element, let's say I wanna access the element 2. So we already know that if we are starting our rows from 0, then 1 2, right? So it will be in the 0th row and first column. Okay, so if I print, let's say system, let's say I'm printing system dot out dot print, and here I'm printing ARR of 0th row and first column. Okay, and just print it out. You can see that it should give me output as 2. So let me print it. I'll go to cd 3 dot space 2d space arrays, and too many arguments. Let me copy this. Okay, uh, here cd give it. Let me remove space in this folder. I think because of space I'm getting this. uh, okay, rename, remove extra spaces, 2d array will be enough. Okay, while I'm uploading to GitHub I'll change it. Okay, no worries. And yeah, so let me cd 2d 2d space, we can't use space, right? So okay, so cd give it. I hope this will work. Not too many arguments. Why it is showing too many arguments? uh clearly clear, and I'm in DSA folder, 2D array, uh and yeah, it is all right. Okay, let me do one thing. I'll put it outside for now, and let me run my code. Java to array dot java. It should give me the output as 2. So you can see that it is showing some sort of error. Why this error? because I need to give class name as DSA. So I'll give DSA, and this will not give me any error. Just let me save it and run now. Celia clear and run it. uh, Java DSA dot Java. I hope this should not give me any error. You can see that I got the output as 2. Like this, we can access a particular element. Now let us see how to take input from the user, how to access element, how to print elements one by one, all this sort of things. So first of all, let us see how to print the output, or you can say all elements, how to print all elements in the given array. For that, what I'll do is that I'll run my loop for int I is equals to 0 and I should be less than. If you remember that here we have, like in one dimensional array, to get the size of a single array we use arr dot length, and they will give me the total number of elements present in this straight line. So I'll write arr dot length, so it will give me the row length. So total number of rows will get from arr dot length. Now if you want to get how many columns are there, I will write here, let me show you. I'll write I plus plus. Now in the inner loop, I'll write for int j is equals to 0 and j, uh, here j should be less than arr of 0 dot length, and I plus plus. In this I'm gonna print error of I, error of j, that particular cell, and I'm printing that. After that I'm printing the next line, and that's it. That's pretty much it. So let me save it, and why it is showing some sort of error, used to enhance for the loop iterator over array, whatever, leave it. I hope it's not error. It's not error. Okay, so what I'm doing here, so if you remember that we need the total number of rows, total number of columns to print the elements present in the array, present in my two-dimensional array. Now the outer loop represents the total number of rows. This represents total rows, and the inner loop, this inner loop represents total number of columns, and to get total number of columns we use this arr of 0 dot length, and to get total number of rows we use arr dot length. I hope you guys are very clear how to print the elements in the given array. Now if I print it now, then I should get output 1 2 3, in the next line 4 5 6, and after that 7 8 9. Let's see what we are getting. I'll run my code. You can see 1 2 3 first row, 4 5 6 second row, 7 8 9 third row, and numerically, or you can say mathematically, we represent with 0 1 2. So this is 0th row, first row, second row. Even though there are three rows, total number of rows are 3, but the representation starts from 0, because we use zero based indexing. Now let us see how to take input from user. So I have given my manual input. Now if I want to take input from the user, then what I'll do is that first of all I'll create my scanner class, scanner sc is equals to new scanner, and after that I'll create my new two-dimensional array arr is equals to new int, and I have to give the size of the array as well, like how many number of rows, how many number of columns I'm gonna have. Let's say I want to create a 3 cross 3 matrix. It means that in my array there will be 3 rows, 3 columns. So I'll give 3 3, that's it. So this will create a two-dimensional array with 3 rows and 3 columns. Now after that, what I'll do is that I'll take input from the user. So here I'll run my loop, and instead of 3 I'll write arr dot length. Okay, and here also arr of first row, total number of elements present in first row. So arr of 0 dot length. Okay, so this represents the number of columns. Now after that, what I'm doing, at every cell I'm going to every cell and I'm asking the input from the user. Okay, now yeah, That is pretty much it. Now after that, what I'm gonna do is that I need to give another bracket, closing bracket. Now what I'll do is that I'll print the matrix. Now I'll print the given matrices and the outer loop, inner loop, and the elements present in it. Okay, so closing bracket and closing bracket, that's it. So let me save it, and after every row printing, I'll print system.out.print. That's it. Next line. Let me save, and here first of all clear all this. Now run again. You can see it is asking enter the number of elements, so I'm giving 10. After that 19, like this I have to give 3 cross 3, it means 9 element. So 11, 12, 13, 14, 15, 16, 17, 18. How many elements are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope these are enough. You can see I have given 9 elements which are 3 cross 3, and the generated matrix I got is a 3 cross 3, number of rows 3, number of columns 3, and this is the matrix I got. So I hope you have understood how to create a matrix, how to use elements, how to access elements, print elements, taking input from the user, and all this sort of things. So till now I hope the overall foundations of a two-dimensional array is clear. Now let us go and understand the questions related to a two-dimensional array. So the first question we are having is spiral matrix. This is a very spiral matrix. So this is a very interesting question, and this is a top level question. You can find this in lead code hackering in every coding platform. Okay, so in this user will give me 1, 2, 3, 4, 5, 6, 7, 8, 9, and I need to travel in this spiral format, and whatever the elements I'm encountering in this fashion, I need to print those elements. So the output will be uh, 1, 2, 3, 6, 9, 8, 7, 4, 5. In this spiral format, whatever the elements I'm printing, in this spiral format, whatever the elements I'm getting, I need to print those elements. So how I'm gonna do it? So if you can observe very clearly that what is happening in this array is that first of all I'm printing this array, this first row, after that last column, last row, and first column. Again after printing the outer part, I'm going inside and this will happen again. Okay, so you can see that first left to right iteration, I'll say this as right iteration. First right iteration is happening, after that down, and again I'm going to left side and top side. After printing all these four things, I am contracting my loop, making it smaller. For example, let's say there are multiple elements, like here first of all I'm printing this thing. After printing this thing, I'm going inside and I'm printing this. I hope you guys are clear visually what is happening here. Okay, so I'm contracting the loop, and again I'm continuing the process, which is right. I'm printing the elements from left to right, top to down, which are going down, after that going left, and again going top, and again contracting elements. This contraction will happen until and unless my rows and columns become one. Okay, what is the meaning of rows and columns become one? So I hope like we have a very we got a very vague idea ki what is happening here, what we are doing here. That first of all we are printing elements this way, bottom, top, and after printing the outer loop we are going inside, we are taking the element in the same fashion, printing them, coming inside. So something is happening, and that something is like we have a starting column, we have a starting column, starting row, ending column, ending row. and every time we are going inside, we are increasing the starting column. So we have four things here. One is starting column, starting column, starting row, ending column, and ending row. Okay, and every time we are contracting, my loop, you can see that this is row 1. Let me show you here. This is row 1, uh, which is my starting column, starting row, sorry, this is my starting row, right? And you can see that this is my ending row. Let me remove this arrow. Okay, this is my ending row. Now this is my ending column. Just observe the diagram, guys, you will understand in a very clear manner. And this is my uh, starting column. Okay, now after completing the outer iteration, after printing the right, down, uh, left, top elements, what I'm doing, I'm coming inside. So here I can see that the row, this row is increasing, my starting row is increasing now, and the ending column has decreased, and ending row is also decreased, because you can see that from bottom I'm going up. When I go up, the index of that particular row will decrease now. After that, my starting column will also increase. So every time when I'm contracting, what I'm doing, whenever a contraction is happening, I am incrementing my starting column, I am incrementing the starting row, I am decrementing start ending column, I am decrementing ending row. And while I'm doing this, I'm iterating top, which is my left, down, right, and top. This thing will continue, and we'll see how this, like how to print left, down, top, right. It is easy, it is very one line loop code, easy to understand. When I write it, you'll understand, but I hope you got the point. Key first, initially perform uh, right operation, down operation, left operation, top operation. After performing one complete circle, contract the circle and do the same, contract the circle, do the same, contract the circle, do the same, until and unless you get a final element, you get a single element. Okay, and in this case you can see that the single element here is 5, and at 5 will stop our loop. So can I write that for this four things we will have loop, one type of loop, and for this thing we'll have one type of loop. Okay, so if I have to write my pseudocode, if I write my pseudocode here, I can write that while my starting column should be less than or equals to my ending column, and my starting row should be less than or equals to my ending row. Until and unless I hit this condition, I will keep iterating in my array. And what is my first work? I need to print the right part. From left to right, I need to start right. So here what I'll do is that I'll begin with my starting row. Okay, so initially I'll write here, initially my starting row will be 0 and my ending row will be 0, ending column, starting column will be 0. Okay, now what I'll do is that I'll start iterating here. When I'm moving on right side, I'm changing the column, right? The row is same, but I'm changing the column. So what I'm doing is that I'll go for I is equals to 0 to arr dot length, and in this I'll print arr of I, arr of starting row will be the same, but I'll change the column, and in the whatever the elements present here, I'm gonna print it, in the output screen. So this is the loop for my right side. Now for the downside, I'll start This is the position I'm at. After completing the first loop, I'll be here, but I need to start it from here. So let me show you. Ki this is the array I'm having, right? 1 2 3 4 5 6 7 8 9. Okay, so after completing the first loop, I will be here. Now I need to start from here, right? I don't have to print 3 2 times. So the right loop will print element 1 2 3 on screen, and if I start from here now, then I'll print 3 2 times. I don't have to do that. I'll start from this 6 element. So what I'll do is that I'll write j is equals to my ending column plus 1, right? So ending column plus 1, and I'll keep on going. I'll keep on going to the size of the element, which is j is equals to ending column plus 1, and I'll keep on going till my I reach my end of the array. Okay, end of the array. So here I'll write err dot length and j plus plus. In this, what I will do is that I'll print the elements in the array. So err of j and my ending column. This will give me the last element, last end column elements. End column elements. Okay, now after that I'll print the bottom, which is from right to left. So from right to left I'll print. So for I'm at the last row, and I'll go till to the first column. So here I'll do the same, that uh, int I is equals to my end of row, not end of column, end of column, and j should be less than or equals to my 0th column, and I'll print the element system dot out dot print err of end row and j. Okay, now after that I'll print the final loop, which is I is equals to I am at the end of the row, and I'll keep on iterating to the first column. So end row and I should be greater than or equals to 0, and I'll print system dot out dot print and err of here I will move row wise, right? So I will write I and my first column, starting column. After completing this for loop, this first loop represents for right side, the second loop for down side, the third loop for down left, and the fourth loop is for top. Okay, after performing this 4 loops, I will increment starting column. I'll increment the starting column, and I'll increment the starting row. After that, I need to decrement the starting row, decrement the starting column. So I hope you have understood. Very easy to understand ki what is happening. Once the diagrammatic visual representation is clear, the code will be very clear. Okay, now let me go to Visual Studio Code and show you ki how things work there. So I'll create a function. Let me write the function name as public static void spiral underscore matrix, and in this user will give me array. So what I'm doing, first of all I'm calculating the starting row, starting column. After that I'm calculating the ending row, ending column, and while my ending row and starting row is greater, ending row and ending column is greater than my starting row and starting column, I'll keep on iterating, I'll keep on running my while loop. Now after that I'll print the top element, right element, bottom element, left element. Like this I'll continue. After doing that I'll decrement and increment this. So I hope you have clear key what we are doing here. Now instead of taking input and all this sort of things, I'll just give a array explicitly err, and I'm using this array. Okay, now I'll call my spiral matrix. So for this particular thing, my output will be my output will be 1 2 3 4. After I'll go to 5 12 16, something like this. This should be my output. Now let me save it, and what I'll do is that let me clear and print it here. So let's see what output I'm getting. You can see that from spiral matrix the array I got is this. So this is a very classic example, very classic question, and you will find this in different coding platforms. The next question we are going to talk about is square diagonal sum. Interesting question. This is also a very interesting question. Let me go down and zoom it to 100. So in spiral, not spiral, diagonal sum, in this question what we are gonna do is that key user will give me an array, let's say 1 2 3, and user will give me a n cross n array, and I need to tell key how we can what is the sum of primary diagonal and secondary diagonal. So let's say 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 and 16. So you can see that I have a 4 cross 4 array, and this will be my, let me draw a line. I know my diagrams are very bad, but bear with me. Let me draw a line. So this will be my primary diagonal. Okay, this will be my primary diagonal. Okay, and this should be my secondary diagonal. So I need to calculate the sum of primary diagonal and secondary diagonal. Okay, secondary diagonal. Okay, so let me skip it for now. You can see this is my primary diagonal, this is my secondary diagonal. Now the sum of primary diagonal here, the sum of primary diagonal will be 1 plus 6 plus 11 plus 16, and secondary diagonal sum would be 4 plus 7 plus 10 plus and 13. So I need to calculate the sum of these two. Now how to do that? If you observe, observation is all we need. Now what is the index of 1, what is the index of 6, what is the index of 11, and what is the index of 16? So if you observe the indexes, you can see the index of 1, the index of 1, I am writing the primary diagonal elements. Okay, these are my primary diagonal elements 1, and the index of 1 is 0 comma 0. Okay, this is 0 1 2 3, 0 1 2 3, 0 base indexing. So we will start from 0th column, 0th row. Now the 6 element index will be, you can see 1 1, so it is 1 comma 1. For 11 the index is 2 comma 2. For 16 the index is 3 comma 3. So can I say that if my element, if uh, it is a, if it is a primary diagonal, then the I which is the row value will be equals to my column value. If this is the case, then it is a part of diagonal element, and you need to consider that element as a sum. So what I'll do is that while calculating primary diagonal, I will iterate to each and every element. I'll check the condition whether I is greater than j. If this is the case, then take that element and add it. So I will start my normal loop traversal, and while I'm traversing, I'll check whether I is equals to j or not. If it is the case, then it is a primary diagonal. It is an element belongs to primary diagonal, and add it in the resultant. As simple as that. Now I hope you got the logic for primary diagonal. Now for secondary diagonal, you can see that the element is 4 and the index is 3 comma, sorry, 0 comma 3, 0 comma 3, and for 7 the index is 1, sorry, 2 comma 1. Okay, and for 10 the index is 1 comma 2 comma 1, 2 comma 1, and for 13 The index is 3 comma 0. So can I say that the sum in secondary diagonal, the sum of I plus j should be equals to n minus 1? If this is the case, then the given element is a part of secondary diagonal, and consider that element as a secondary diagonal and keep on adding that element, and you will get a final resultant for your answer. So I hope you got the sum of primary diagonal and secondary diagonal. Okay, like this we can calculate. Now let us say that in the user, in the question, user has asked us ki tell me the total sum, tell me the total sum. So the total sum would be primary diagonal sum plus my secondary diagonal sum. Clear? But here we have 4 cross 4 matrix. That's why the elements are not intersecting. There's no element in between the intersection of primary diagonal and secondary diagonal. But if you take odd square matrices, for example 3 cross 3 matrix, so when you take a 3 cross 3 matrix, now let's say 1 2 3 4 5 6 7 8 9. So in this you can see that let me draw a line here. So this is my primary diagonal, this is my primary diagonal, and this is my secondary diagonal. You can see that there is a intersection element in between it. Now the primary diagonal sum would be 1 plus 5 plus 9, and the secondary diagonal sum would be 3 plus 5 plus 7. And you can see that it will give 6 plus 9, which is 15, and this will give me 10 plus 5, which is also 15. But you can see that if if question ask me that give me total sum, give me total sum, then primary diagonal plus secondary diagonal, you can see that the total sum would be 1 plus 5 plus 9 plus 3 plus 7. It will give me 10, 10, which is 10 plus 10 20. The answer would be 25. But if I combine primary diagonal sum plus secondary diagonal sum, it will give me 30, and obviously the answer is wrong. So in this case, you need to make sure that in secondary diagonal the first condition should be I plus j should be equals to n minus 1. N is the total number of size of the array. Now the second condition is I should not be equals to j. These two conditions should be satisfied. You have to check these two conditions for secondary diagonal, and for primary diagonal this single condition is enough. Okay, so I will iterate, the code will be, I will iterate in the entire array for I is equals to 0 to n, or you can say total number of rows, and in that I'll iterate my inner columns, which is j is equals to 0 to my total number of columns, and I'll print system dot. Before printing I need to check. So if I is equals to j, then this is my primary diagonal. So my primary, initially I'll initialize primary diagonal with 0, secondary diagonal with 0. So my primary diagonal will be is equals to ARR of I and j. Okay, now the condition for secondary diagonal is I plus j should be equals to n minus 1, which is the total number of size of the two-dimensional array minus 1, and I should not be equals to j. If this is the case, then this is the case for secondary diagonal. So I will add it in the secondary diagonal, error of I and j. Like this, we take the sum of primary diagonal and secondary diagonal. If user asks us to print the total sum, then I can simply print secondary diagonal plus primary diagonal. As simple as that. Now let me code it. So here I'll write my function public static void diagonal sum, And initially, let me remove all these things. I'll write my own code. Int primary diagonal, int primary underscore diagonal is equals to 0, secondary diagonal is equals to 0, and I will run my outer loop. And in the outer loop, we already know that the element, the primary element, primary diagonal element would be here. Let me run my inner loop as well for I is equals to 0, and you can see that if I is equals to j, then I'll add it in the primary diagonal. If I plus j is equals to this, and I should not be equals to j. If this is the condition, then I'll add it in the secondary diagonal. Now after adding all the elements here, I'll print the total sum in total sum is equals to this, and I'll print the total sum of the given array diagonal sum of both diagonals is this. Okay, now let me clear this. So you can see that this is a 4 cross 4 matrix, and when I run it now, I hope my answer would be, I don't know what the answer would be. Let me comment this out here. Let me comment it out. Okay, and I'll call my diagonal sum, and for this the answer would be 68. So let me save it and run it again. So you can see that the sum of the given array, the given two-dimensional array is 68. Like this, we calculate the uh, diagonal sum of the given element. So till now we have talked about two questions. One is spiral matrix and another one is diagonal sum elements. Now the next question we are having, this is the final question of the class. After that we'll leave and we'll see you in the next class. But yeah, the final silly easy question is searching. So in searching, what is happening, like if you remember, we have studied two different types of searching. One is binary search, one is linear search. So let's say I have a two-dimensional array 0 1 2 3 4 5. Now user asked me to search whether the element 5 is present in my given array or not. So for this also we have two approaches. One is linear search, where I will go each and every element and I'll search whether 5 is present or not, 5 is present or not, and this will give me n square time complexity because I am iterating each and every element. Now the second method would be applying binary search on a two-dimensional array. How I'm gonna do that? So the logic of applying a binary search on a two-dimensional array is I'll consider one row as a single dimension array, and in that I'll search it. Interesting, right? So the code, let me show you the code, and after that you'll understand it in a very clear manner. So what we used to do in my uh, in my binary search, I used to take the first element, last element, calculate the mid, break it down in two parts and check whether the key is present on the left part or whether the key is present on the right part. Okay, now in this condition, in this case, what we do is that here I'll run my loop for I is equals to 0 to n. Okay, I'll iterate each row, and while I'm doing that, I'll start off while my j represents the starting column, j is equals to 0. Okay, j is less than or equals to my ending column, which is arr of 0 dot length. Okay, now I'll calculate the starting here. This is my starting index and this is my ending index. So ending index is equals to arr of 1 comma or I comma length. Okay, now I'll calculate the mid value. Mid is equals to starting index plus ending index divided by 2, normal binary search, and again like the same if condition, mid is equals to key, return mid value, sorry, mid value. Now if my mid is greater than key, then search it in the left side. If my mid is less than key, then search it on the right side. And this is the overall code for my binary search. So here the outer loop will take n and the inner loop will take n log n. So the total time complexity will be n plus n log n. Okay, so let me go to the code, and here I'll write my code for binary search. Public static void 2d 2d array 2d array underscore binary search. You can see that I have calculated the row value and column value, and what I'll do is that key I'll remove all this. Okay, now what I'm doing, first of all, I'm running a loop for int I is equals to 0 to I should be less than arr dot length. Okay, now inside that I'm calculating the starting index, middle index. So int starting index is equals to 0, int ending index is equals to arr of 0 dot length, and after that I'll running my loop while starting is less than mid, and I'm running this. So this is how I'll calculate my mid value. Okay, uh, key is not found, and here I'll print the key. Okay, let me save and let me pass the key here, comment this out. Okay, I'll write my 2D binary search and I'm passing 7. So you can see that this should give me the key found at 7. Okay, so let me save, and it is giving me some sort of error. The key found at index 1 comma 2. So the 7 is present at the index 1 comma 2. So I hope you have understood key what is two dimensional array, how to use it, how to create them, what are the concepts involved in two-dimensional array, and we have solved many questions related to two-dimensional arrays. Now what I'll do is that I'll provide you the GitHub link for this entire code base. You can access it, test it out, check it yourself. Now in the next class we'll talk about strings in detail. So with that being said, I'll see you in the next one. Bye.